Alternating current in an electrical circuit. Electric current that reverses its direction periodically many times in a second is called alternating current. AC circuits are widely used from household appliances to electric motors, and sine waves are used to represent these electric currents. AC circuits have many components, and these components offer an opposition to the flow of electric current, while resistors offer resistance. The opposition from other components is called reactance. It can either be capacitive or inductive. Since resistance and reactance are two different properties and cannot be plotted in the same equation, complex numbers help do so, where reactance is taken to be imaginary and resistance is taken to be real. Complex numbers are widely used in such cases where representation of a problem is impossible with only real numbers, such as electromagnetism, aerodynamics, and the Fourier transform.
Now let's recall some basics of complex numbers. The complex number j is represented as the square root of -1. As we can see from the Eigen diagram, the complex number consists of a real part, that is x, and the imaginary part, that is y. The two forms of complex numbers are rectangular form and polar form. It is necessary to know how to convert from rectangular form to polar form and vice versa. The formulas shown above are used for the conversion. It is important to remember the two basic general rules of complex numbers. That is, when adding or subtracting, the complex number should be in rectangular form, and when multiplying or dividing, it should be in polar form.
Complex numbers simplifies the calculations for AC circuit analysis when inductors and capacitors are introduced into the circuit. There are two important elements to consider in AC circuit analysis in the way we describe voltage and current. These are the magnitude and the phase angle. As a result, phases are often used to represent these values. The phase angle is the phase difference between current and voltage. As you can see, the method of working out magnitude and phase angle of a phasor is the same technique as used for complex numbers. This is because in AC circuits, inductors and capacitors introduce another form of impedance called reactance. Reactance is the effective resistance by a capacitor or inductor in an AC circuit, and introduces a phase difference between a voltage and current. As you can see, reactance is at a 90-degree angle to resistance, and total impedance is the addition of the phases. When inductors are introduced into the circuit, a positive phase shift of 90 degrees is created, where voltage leads to current. However, capacitors introduce a negative phase shift of negative 90 degrees, where the current leads to voltage. This means the resulting impedance of an AC circuit with capacitors and inductors can be represented on an Eigen diagram, which means calculations can be greatly simplified using complex numbers. In summary, complex numbers can be used to model the effect inductors and capacitors have on current and voltage in AC circuits. This means that resistance is represented on the real axis and reactance is represented on the imaginary axis.
Hi guys, now let's take a look at an example. Our problem is to find the total impedance from the following diagram. In AC, we have general equations like ZT is equal to R plus HL minus HC. By equating them, we can find HL is equal to 245.04 J ohms and HC is equal to minus 1.768 J kilo ohms. And writing them in rectangular form is like simply ZT is equal to 250 minus J 1.5233 kilo ohm. And to convert them into polar form, we have Z is equal to 1.5437 kilo ohms and theta is equal to tan inverse of B by A, which is minus 80.680 degree. So Z total in polar form is equal to 1.5437 kilo ohm and angle minus 80.680.